Alright, today we are working on section 2.5, which is implicit differentiation. Now the difference between implicit and explicit differentiation is that implicit often has x and y on the same side, and we're still needing to solve for y. The explicit is what we've been working with so far, where it's always y equals, and we have everything in terms of x. Now the derivative of the explicit form of this one we know it is negative x to the negative 2, or negative 1 over x squared. Today we are going to be working with examples where we don't always just have y equals, simple like that. So here we are taking the derivative in terms of x, that's what this means, in terms of, and of x cubed. And here our variables agree, and this is what we've been doing so far, where our variables agree with one another. So the derivative of this is 3x squared. Now in this case we have d dx of y cubed. Now the variables obviously do not agree on this one. So what you do is take the derivative like you normally would. This would be 3y squared, only this time when you take the derivative of a variable that you are not with respect to, then you have to add dy dx on the end. This means here we took the derivative of y in terms of x. You have to do that every time you take the derivative of anything other than x. So in C, we do have an x term, so that one is basic, that's just 1. And then we have to multiply on 3, but because it was a y, we have to do dy dx on the end. Part D is a product rule, because we have two functions. Even though the variables don't match, we still have to do the product rule because there are two different functions. So x times y squared. The product rule is fg prime plus gf prime, so we leave f alone, take the derivative of y squared plus g times the derivative of x. Okay, this is just the process. We haven't actually taken the derivative yet. So now we're going to actually do the d dx portions of this. X times d dx of y squared is going to be 2y dy dx, because we took the derivative of a y term, plus y squared times 1. So if I was to simplify this a little bit, it would be 2xy dy dx plus y squared. So you're still doing the same process, you just have to remember when you're taking the derivative of a y term to put that dy dx on the end of it, or you're not going to get the right answer. So our guidelines do the same thing with respect to x. That means that you have to do a dy dx every time you take the derivative of a y term. Then you're going to take all the terms that have a dy dx to one side of the equation, generally the left side, and move everything else to the right, and you're going to factor out the dy dx and then solve for it. So we do need to do a couple more steps than what I showed you so far, but these are the steps for any implicit differentiation problem. All right, find dy dx given that y cubed plus y squared minus 5y minus x squared equals negative 4. So take the derivative just like normal, and we are going to solve for dy dx this time. So 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x equals 0. So we need to move everything that doesn't have a dy dx to the other side, and it's going to be much easier to do it that way since we only have one term to move over. And then in the same step, I'm going to take the dy dx out of the left side. So every term had one in it, so we're going to take it out. And then I want to solve for dy dx, so I need to divide both sides by this whole thing. Once I do that, I have dy dx alone, and that was my answer. So we can have both x's and y's in our answer. That's okay. Okay, if possible, represent y as a differentiable function of x. Well, in this case, x squared plus y squared equals 0. If we think back to advanced algebra when we were doing conic sections, this is the equation of a circle, only our radius is 0. So this is actually a point. graph is a single point. It doesn't define y as a differentiable function of x. So we actually can't even do this one. Okay, how about b? So this is the same thing. X squared plus y squared equals r squared. This is a the circle with radius 1. Circle radius 1. So the top half, 1 minus x squared, this is the top. And then we would also have the negative. That would be the bottom half. Here's our top. Here's our bottom, because we can't just graph that whole thing at once. Y squared equals 1 minus x squared. We have to take the square root, which is why we have two sections to it. Part C is also a conic section. This is a parabola. That looks like that. And again, we're going to have two different sections because we have to take the square root. 1 minus x and negative 1 minus x. This is the top. This is the bottom. Determine the slope of a tangent line to the graph of x squared plus 4y squared equals 4 at the point square root of 2, negative 1 over square root of 2. So the first thing we need to do is take the derivative, and we are going to have to take the term in terms of x. So every time we take the derivative of a y term, we have to do dy dx next to it. So 2x plus 8y dy dx equals 0. This one's not too bad to take the dy dx out of. I'm going to move the 2x to the other side, so it's negative. And then we had to divide by that 8y. So our dy dx is negative 2x over 8y. And we can plug in our point. We have to actually plug in both the x and the y this time. Negative 2 times the square root of 2 over 8 times negative 1 over square root of 2. Actually ends up being 1/2 when simplified. Now is it just trying to find the slope. Determine the slope of this graph at point 3, 1. This one is a little bit more complicated than what we just did, but we're going to start the same exact way. We're going to take the derivative in terms of x. So on the right side, that one's the product rule. Let's start on the left side though, because it's a little bit more complicated. Take the 3, the chain rule, times the derivative of the inside. The right side is the product rule. 100x dy dx plus 100y. Now we want to get all the dy dx terms on one side, so we actually have to distribute through on that left side. I have moved all the terms over that had the dy dx in them. Factor out the dy dx on the left side. And divide. So our dy dx ends up being 100y minus 12x times x squared plus y squared over 12y times x squared plus y squared minus 100x. Now we are plugging in 3, 1. So 3 everywhere that the x is and a 1 everywhere that there is a y. We end up with 13 ninths. Same thing, just trying to find the slope. You actually could simplify dy dx a little bit, but it's for all intents and purposes, it's just if they were solving for dy dx, you would want to simplify, but because we were just trying to find the slope, you can just plug in the numbers whenever you have something that's easy to work with, which I think we were at that point. Find dy dx implicitly for the equation sine of y equals x, then find the largest interval where negative a is less than y is less than a, on which y is differentiable. So check the derivative first. Cosine y dy dx equals 1. Dy dx equals 1 over cosine. So we're trying to find an interval where 1 over cosine is differentiable. Okay, this is kind of what your function looks like. This point is pi over 2. This point is negative pi over 2. So your interval is negative pi over 2 to pi over 2. And we know this is our y. So negative 1 to 1 would have been our x, but we are looking at the y. So that is our answer. Finding the second derivative implicitly. That just means take it twice. So let's just take it first. Dy dx is negative 2x over 2y, which is negative x over y. Then we're going to take the derivative again of our answer, negative x over y. Y times negative 1 minus x dy dx over y squared. And now we have dy dx up here. We're actually going to plug that in right there. So negative y minus x times negative x over y squared equals negative y squared plus x squared over y cubed. And from up above, we know that x squared plus y squared is 25, so we actually have x squared plus y squared right here. So negative 25 over y cubed is our final answer. And last thing we're going to do is find a tangent line to a graph. So we have to take the implicit differentiation of this. It's going to be easiest to distribute this through. And then take the derivative. Or if you'd like to get everything on one side, that might be easiest too. Okay, now I'll take the derivative. 4x cubed plus x squared times 2y dy dx plus 2x y squared minus 2y dy dx equals 0. Keep all the dy dx terms on the left side. We have 2y times x squared minus 1 equals negative 2x times 2x squared plus y squared. Dy dx is x times 2x squared plus y squared over y times 1 minus x squared. Now obviously I have simplified a little bit, taken 2's out where it's necessary and simplified. Now we want to know what the slope of this is at square root of 2 over 2. Square root of 2 over 2. We plug that in. dy dx is 3. So our line is y minus root 2 over 2 equals 3 times x minus root 2 over 2. And that's good enough for me there. Homework assignment is on the bottom, and that is implicit differentiation.